Yeah, so like I said, today's class we're going to continue talking about the curve sketching, the sketching of the exponential graphs. Then, if we finish on time, we do the sketching of the logarithmic graphs. Then that is the lane graphs. Then, if that one too goes well on time, then we'll move on to series and series. So series, we're going to talk about the arithmetic progression, geometric progression. I don't think we'll be able to finish up that, but that will be the next topic we're going to do in school. So at least I know that the logarithm is better. It's better than we started. We've solved a lot of questions, but there are more questions to solve. So you go through the past questions, questions that are from 2021. Yes, 2021, 2022. Go all the way to 2024. Keep trying the questions about that. We get?
Yes.
Okay, so what do you remember about what we did the last time?
So say you taught me this like trick. So then we draw like a U, like for the positive aspect, I think.
Yeah, continue. Understand.
You draw like a U and you divide it into two. The left side is negative and the right side is positive.
Okay. What else?
Um, you did same for the negative, I think.
Okay.
Yeah. And then we solve some questions.
Okay. A minute.
Okay. We can go to
So let's continue. So we're going to look at. Yeah, I think we went through already. So try to sketch this one for me. Hope you can do it.
yes. C'est bizarre même.
Okay, send it to me.
Yeah, I'm going for my phone. Okay. So I've sent it.
Okay. Okay. So let's look at the general way to sketch this one. Just like the quadratic curves. I told you that a positive quadratic curve looks like a smile, and a negative quadratic curve looks like a frown. After all, positive things will make you smile, and negative things will make you frown. So we're going to extend the same knowledge over here for the exponential functions. So for a positive exponential function, that is also going to look like sort of a smile, not really like a smile, but sort of a smile. So that's how it's going to go, this way, then this way. So there's a positive exponential function. And a negative exponential function, that is when we've got this one to be y is equal to e raised to the power x. and a negative 1, that is y equal to negative e raised to the power x. That is going to give you the frown like something. So there's going to be this way, and it's going to be this way too. Are we good?
Yes, sir.
Okay, so this one represents the positive x-axis. So there's e raised to the power x, and this represents the negative x-axis. So e raised to the power negative x. Now when it comes to this one, this represents the positive. So there's negative e raised to the power x, and there's negative e raised to the power negative x. Because there's at the negative side. If I'm to draw the Cartesian plane, there's the negative side and there's the positive side. Is that okay?
Yes, sir.
So you can use this one as a guide, and you can draw this one up. That will make your learning easier. So kind of like do it this way and do the representation. You get?
Yes, please.
Okay. So back to the question over there. Y equal to e raised to the power 2x minus 4. We did mention about the asymptotes, where the asymptote is going to be, and the asymptote is going to take the last value. Remember from last week's class?
Yes.
Okay. So there's going to be an asymptote at negative 4. And I'm going to use short dashes to represent the asymptotes to tell the examiner that it's not part of the work, but it's just going to guide us to get the answer to the question. So that is the short dashes over here. Then we move on to find the orientation. There's a positive exponential function. So a positive exponential function will look this way. Will look this way or this way. So this e raised to the power x. So we are looking at this one. So we know it's going to go upward in this fashion. We can now find the y-intercept. For y-intercept is equal to 0, this goes to 0. So the y-intercept is going to be at negative 1. So there's going to be y-intercept at negative 1. And we can also find the x-intercept. But because you know the orientation, let's just draw this one. Then we find the x-intercept and we'll put that value there. So the x-intercept with this will be when y equals to 0. So this will literally give you 0 is equal to 3 e raised to the power 2x minus 4. Then 4 is equal to 3 e raised to the power 2x. Then 4 over 3 equal to e raised to the power 2x. Taking lane of both sides, so lane of this and lane of this, you can get lane 4 over 3 is equal to 2x. Then you find x, which is going to be 1 over 2. So this 1 over 2 lane 4 over 3. And this becomes a graph with the x-intercept being this and the y-intercept being negative 1. Is that okay?
Yes, please.
Okay. So let's do more. Let's sketch the graph of y is equal to 2x. Sorry, it's y equal to 2 e raised to the power negative 5x plus 8. So the same thing. There's a positive exponential function because the 2 is positive. So a positive exponential function looks like the smile I was talking about this way. So there is the e raised to the power positive x and e raised to the power negative x. So in this graph, we are interested in this part. So the graph is going to look something like this. Is that okay?
Yes, sir.
Okay. Because the exponent of the e is negative, so it's going to look something like this. Now, let's get everything sorted. We know the orientation, and let's look at the asymptotes, then the intercepts. So in this case, the asymptote is going to be at 8. Let me introduce that with my short dashes. So let's say that y equal to 8 is the asymptote. So y equal to 8. Then we can find the x-intercept. For x-intercept, y equal to 0. For y-intercept, x equals to 0. So y-intercept first, since it's easier to find. This will give you to be 10, if my math is not wrong. That is x equal to 0. This will give you y is equal to 2 e raised to the power 0 plus 8, which is equal to 10. And this for this 8. So 10 should be here. We all want the orientation of the curve to be this way. So I know it's going to go down the asymptote. I'm not touching it. Let me do it well. Then it's going to go up. It is so obvious that there is no x-intercept. But let's attempt to find the x-intercept and let's see what happens. If you know the orientation of the curve, it saves you some trouble. So for x-intercept, we know that y equals 0, right?
Yeah.
So this gives you 0 is equal to 2 e raised to the negative 5x plus 8. So the 8 goes to the other side, negative
I already solved it. Too.
Come again?
I already solved it.
Okay, so what did you get?
Negative 1 over 5 ln negative.
Okay, so there is a problem over there because the logarithm can take negative numbers.
Yeah.
So negative 1 over 5 ln negative 4. This will give you a math error. This is not defined because of the negative 4. So the conclusion will be there is no x intercept. And you could see that it was clear over here when we did a drawing. So the orientation of the curve is very, very important. So once you can determine the orientation of the curve, some of the calculations won't be so necessary. That's okay.
Yeah.
Okay, great. So let's do another one together so that at least I know I've solved multiple of this with you. Normally, this kind of sketch comes in a function question, not really logarithmic questions. So, and we've not done functions too, but at least you guess what I'm doing, right?
Yes.
So negative 2 e raised to the power negative x plus 4. Now, with this one, is it a positive exponential function or a negative?
Negative.
Why is it negative? Is it because of the negative x or the negative 2?
Yeah, because it's negative 2.
Okay, because of the negative 2. So, there's going to be looking this way or this way because it's going to look like a frown. Now, there is the positive negative e raised to the power positive x and negative e raised to the power negative x. So I know my curve is going to look like this. So I'm interested in something like this one. Are we good?
Yes. Yeah.
Okay, let me move this to the top. Okay, so from here, you can put our Cartesian plane. There is an asymptote at positive 4. So y is equal to 4. There is an asymptote over there. And I can write a 4 over here. We can find the y-intercept. So for y-intercept, x equals to 0. So if you find the y-intercept, we can say that there's going to be y equal to negative 2 e raised to the power 0 plus 4, which is equal to 2. So there is an asymptote, sorry, there is a y-intercept at 2. Let me move this one up a little bit. Okay. So there is a y-intercept at 2. This. Now, because we know the orientation of the curve, we know it's going to look like this. So you can quickly draw this one using the asymptote as your guide. Then we know the graph is going to go this way. Is that okay?
Yes. Yeah.
So you can now find the x-intercept. So for x-intercept, we can say that y is equal to 0. So this will give you 0 is equal to negative 2 e raised to the power negative x plus 4. This should give you 2 is equal to e raised to the power negative x. I moved the 4 over there, which is negative 4. I divided by negative 2 so that I don't really waste the time. Is that okay?
Yes. Please.
So lane 2 is equal to negative x. Then we can say that x equals to negative lane 2. So this one will be negative lane 2. And that ends the sketch. Is that okay?
Yes. Please.
Okay. So you can copy these ones down. At least we've done 3 sketches. And I've done it with you.
Yes, sir. I'm currently copy this one.
Okay.
Save this on them.
Okay, good. So let's see if you can do this by yourself. You have to sketch the graph of y is equal to negative e raised to the power 4x plus 2.
Okay, I'm coming. See, I don't remember. My answer looks some way. Yeah. I've sent it.
Why does it look some way? What you're saying looks correct.
The negative 2.
It looks correct. The negative 2. No, there's something wrong.
Yeah.
So you can't get the line of a negative. Okay, so let's see. This is a negative curve. So a negative curve is like a frown. So this way and this way. And there's a positive negative. So negative e raised to the power positive x and a negative negative. So we interested in the positive exponent positive, which is a negative curve. So something like this one. I think you got the orientation correct based on what you sent me. You got the orientation correct. So let's see. Let's see how to sketch this one. First, to start off with the asymptote. In this case, asymptote is at 2. So let's get our imaginary line at y equal to 2. Can I continue?
Yes, please.
For the y-intercept, we can say that x equals to 0. So this will give you negative 1 plus 2, which is going to be a positive 1. So the positive 1 is somewhere here. Now we know that the graph is going to look something like this. So it goes off this way and comes down this way. We get?
Yeah.
Okay, so you got the orientation correct. Let's see if we can find the x-intercept. So for x-intercept, we say that y equals to 0. This will give you 0 is equal to negative e raised to the power 4x plus 2. This is negative 2 equal to negative e raised to the power 4x. So the negative cancels out. 2 e raised to the power 4x. Is that okay? Then ln 2 equal to 4x. How we get?
Yeah.
Are you sure?
Yeah. I see where my mistake
So
is.
x equals to 1 over 4 ln 2. So this 1 over 4 ln 2. And that's ends the sketch for the question.
Yes, sir.
Okay. Are we good with this one?
Yes, please.
Okay. Then we'd have to move on to the log graph. That is a line graph. So this is the exponential graph. And log and exponential graphs are inverse of each other. So in this, we're going to learn how to sketch the graph of this. Pretty easy. I'm not really going to give you some tricks over here. I'll overwhelm you. So we just go with the flow. Y equal to k ln ax plus b. Okay, so this graph will also have asymptotes. Let's go to the GeoGebra. I don't think we'll have to. Yeah, so there's a lane graph. There's also a lane graph. We can see the there are places where the graphs would cross. Let's look at this one too, the blue one. This one too, it has got a weird asymptote. The funny thing about this one, because it's inverse of each other. Remember with the exponential curves, the asymptotes are basically on the y. The values we get are for the y. Is that okay?
Yes.
For the since they are inverse of each other, so if one is for the y, then the other one is going to be for the what? What do you think? The first one was for the y, so the other one, the asymptote will be on the x. How we get?
Yes, please.
They are inverse of each other. So in this case, it's looking like the graph is touching the zero, y x equals to 0, but it's actually not. If I keep zooming in, you realize that this doesn't touch the x equals to 0 line. So the difference between the first one and the second one is that with this one, we are expecting the asymptote to be on an x value. The other one, the asymptote was on a y value. So that's the most important thing I should say for now. We are not really going to go into details with the sketch. So again, we are not going to ask a lot of questions on this unless we're looking at maybe functions. Then we look at some questions over there. Yeah. What can you tell me about the domain of a log function? We've said this already. The domain of a log function. Which values can't log take?
Negative.
Negatives. So values that are greater than less than 0, the log function can take. Okay, so this will give us our first hint to the asymptote. Okay, this is going to give us the first hint to what the asymptote is going to be. So with the first question, we're going to sketch the graph of. I'll use the question to explain what is going on, then we move. Okay,
Yes, please.
sketch a graph of y is equal to 4 ln 2x plus 5. So the same steps over there. With this one, I'm not really going to talk about the orientation of the curve, like know the orientation of the curve, no. The second one we're going to talk about would be the x and y intercept. We should know how to find x and y intercepts. And I'm also interested in finding the asymptote. With these 3 items, it should be okay to sketch the graph by yourself. So let's start off with the asymptote. Because the argument of a lane function or log function can't be negative, the least value is going to, like, let's say 1, like log 1 is 0. What we do to get the asymptote is to equate whatever is inside the argument to 0. That is going to give us the asymptote, the equation of the asymptote. So in this case, 2x plus 5 equal to 0, where x equal to negative 2.5. Are we good with the small calculation I've just done?
Yes, please.
Okay, so this tells me that there's going to be an asymptote at x equals to 2.5. So let me get this one, and let me draw my asymptote. There's going to be a vertical asymptote. So x equals to 2.5. I don't really need to write x equals to 2.5. Let me just write 2.5. Negative 2.5. Sorry. Yeah. Now the next thing to do is to find the x and y intercepts. So for x-intercept, we can say that y equals to 0, and for y-intercept, x equals to 0. Let's find the y-intercept first, since it's easier. So for y-intercept, you say that x equals to 0. This then gives you y is equal to 4 ln 2 times 0 plus 5. So this gives you 4 ln 5. Is that okay?
Yes, please.
Okay, so let's say that is 4 ln 5. I don't know where to put it, so let's assume that is 4 ln 5. So 4 ln 5. Okay. Now the x-intercept. For x-intercept, y equals to 0. So for x-intercept, y equals to 0. Going back to the equation and substituting 0 for y, you get 0 is equal to 4 ln 2x plus 3. To make our working easier, I can divide everything by 4. This will give you 0 is equal to ln 2x plus 3. How would you continue from here? How would you continue to find x?
I can bring log.
Okay, find x. Let's see if you remember your logarithms.
Okay.
So this logarithm, if I want to give you any hint, I'll tell you to change it into exponential. For you not to really worry yourself, this can be written as log 2x plus 3 to the base e, right?
Say -2.
Okay, so x equals negative 2. Nice, right? So this will be 2x plus 3 equal to u raised to the power 0.
I say it's plus 3 or 5.
Is it 5? It's 5 when you
Yes,
add.
5. Yeah.
Okay, so u raised to the power 0 equal to this. So this will give you 2x plus 5 equal to 1, and 2x equal to negative 4, and x equals to negative 2. So x equals to negative 2 should be somewhere here. Let's assume that it's here. It doesn't really look accurate though, but let's assume that is that. So we use the asymptote as a guide. It doesn't touch the asymptote, and this goes that way. Is that okay?
Yes.
And there's the log graph. So it's not so much complicated. Not so much complicated. So you can sketch this one in your notes. So with the exponential function, the asymptote is on the y. It's horizontal asymptote. For the logarithmic function, the asymptote is on the x. It's a vertical asymptote. We good?
Yes.
Okay. When you get to the university, you learn about slant asymptote. Yeah, for now, yeah. Okay, so I should say something to you. Remember we did the asymptote first, right?
Yes, please.
So assuming we didn't do this plotting, someone would ask whether the graph is going to be at this side instead of this side. And when I started the explanation, I told you that the domain of logarithm won't take negative. Sorry, won't take negative, so it should be greater than 0, right?
Yeah.
2x plus 5 should be greater than 0. For simplicity, I just equated it to 0. So when you solve for x, you get x to be greater than negative 2.5. So the graph is anywhere that is greater than negative 2.5. So it won't go to this side because this side will be less than negative 2.5. So that's just by the way. I just said this so that maybe someone watching won't get confused or something. Okay.
Yes, sir.
But it's not really something we'd have to talk about. And later, once you are very good with the sketching, I would introduce you to how to write certain things with a sketch. Like they'll ask you as x approaches positive infinity, what does y do? As x approaches the asymptote, what is y also doing? I'm not so interested in that today. I'm very interested in you being able to sketch. Once you can sketch the curve, you can get out this information with ease. Is that okay?
Yes.
Okay.
Yes, please. Say please, I'm done.
Okay. Let's see if you can sketch this one by yourself. So y is equal to ln 2x plus 4.
Say please, I'm done.
Okay, send me the solution. Wait, okay, just send it to me. Quickly send it to me so that we solve it together.
Say the first line is the short dashes. I didn't see it. So, yeah.
Okay. If you don't indicate it with short dashes, it can be assumed that it's part of your sketch. Okay, so let's indicate with short dashes. So this 2x plus 4 should ideally be greater than 0, where x should be greater than negative 2. So the asymptote is going to be at x equals to negative 2. Let's get something drawn. Let's assume that is my -2. Then I can find the y-intercept since it's easy. So for y-intercept, x equals to 0. So y is equal to lane 4. So let me put lane 4 somewhere here. So lane 4. Then for x-intercept, y equals to 0. This then gives you 0 equal to lane 2x plus 4. So this will give you 1 equal to 2x plus 4. Then this should be negative 1.5. We get? I'm jumping the steps before because I know you can do it with ease. Is that okay?
Yes, please.
Okay, so there's negative 1.5. And this should be sketch. That's as in stations. Okay, so using that as a guide, this should get sketch. And I think you
Yes.
got it. Okay, nice work.
Yeah, I got it.
Nice work. Okay, so let's do a few more. I'll not be able to start a new topic with you, so we just sketch a lot of these ones and we're good to go. Okay,
Yeah, yes, sir.
2 lane 2x plus 2.
So I've sent it to you.
Okay, I've seen it. Okay, you got the asymptote at -1, and you got the x-intercept to be negative 0.5, and the y-intercept to be 2 lane 2. So let's see if that is correct. So for the asymptote, we've got 2x plus 2 should be greater than 0, where x should be greater than -1. So we can say that there is asymptote at x equals to -1. Then for x and y-intercept, for y-intercept, x equals to 0. So for y-intercept, x equals to 0. This will give you uh, y equal to 2 lane 2, just like you rightly got. Now for x-intercept, we can say that y equals to 0. So this gives you 0 is equal to 2 lane 2x plus 2. I can divide everything by 2 to get 0 is equal to lane 2x plus 2. And so far, if you are very observant, you realize that at this point, it becomes 1 equal to 2x plus 2. So take off the lane, there is 0 over here, it becomes 1, then the lane goes away. But you know why it should be so. It's basically me changing from logarithm to exponential functions. This will give you -1 over 2 is equal to x. I think you got all the details on the question. Nice work. Okay, so the first intercept was x equals to -1. So x equals to -1. The next intercept, sorry, the first one was asymptote. The next one is x equals to 0.5 negative. Then the y-intercept was 2 lane 2, 2 lane 2, or I can say lane 4. So using that one as a guide, the asymptote as a guide, I can sketch my curve. Okay, so you got it right. Nice work. Okay,
Yes, sir.
so last question for today. There's a negative lane curve. Let's see how you handle yourself with this. -3 lane 6x minus 9.
Say, please, I've sent it.
Okay, let me check it out. Um, Well, I don't know the answer to this one, so let's solve it. For the asymptotes, we say that 6x minus 9 is greater than 0, should be greater than 0. So 6x minus 9, sorry, 6x, is it plus 9 or minus 9? It's minus 9, so 6x, what did you get for this one?
3/2.
3/2.
1.5.
Okay. A minute.
Okay.
Okay, so 1.5. How is that possible? That's 9 divided by 6. It's not 1.5. Wait, am I mistaken or what? Yeah.
It's 1.5.
Yeah. What is wrong with me? So 9 divided by 6 is 3/2, and that's 1.5. Okay. Then we can say that there's asymptote that x equals to 1.5. Then for x-intercept, y equal to 0. This gives you 0 is equal to -3 ln 6x minus 9. Divide both sides by -3. 0 is equal to ln 6x minus 9. Then 1 is equal to 6x minus 9. Then x equal to 10/6. If my math is not wrong, which is the same as writing 5/3. You get?
Yes, please.
Now 5/3 is 1.2 what?
1.666.
So that one is greater than the asymptote. That is good, because you said x should be greater than 1.5. Then the last one would be for y-intercept, x equals to 0. So this gives you y is equal to -3 ln 6x, sorry, -9. So you can see there is a problem. There is no y-intercept. So looking at your sketch, it's a little bit off. The reason why it's off is that, one, if you had used this one, you realize that we said that x should be greater than 1.5. So all the values of x should be greater than 1.5. But the sketch you gave me, all your values were less than 1.5. Is that okay?
Yeah.
Trying to point out why we weren't right. So this one would guide you. So x is greater than 1.5. And also, you got ln -9 and you still maintained it. Shaman. So this goes.
So it comes to my head. I'm sorry.
So we can say that with this one, there is no y-intercept. There is no y-intercept. In the real domain, there is no y-intercept. Maybe complex numbers there would be, but now there is no y-intercept. Let's get our things sorted out. The first one would be sketching the asymptotes. Asymptotes would be at 1.5. Let's say that's my 1.5. X equals to 1.5. So 1.5 over here. And there is also another one, which is the x-intercept. The x-intercept was at 5/3, which is 1.6. So let's say 1.6. And using this as a guide, we sketch the curve. So using the asymptote as a guide, we sketch the curve. And it goes on that way. Are we good?
Yes, please.
Okay. Okay, so that'll be all for today's lesson. We'll talk about series the next time we meet. So you can read around series, and you can go through your textbook and sketch the curves of the exponential and the log graph. And these are sample questions. Let's see if you can get some sample questions. It will be in functions. Yeah, so there's a question If you go to my study compass, you can download the function paper. With this one, you were told to sketch the graph. With this, you will not be able to do it because I've not said anything about functions yet. So, but in this, I know you can sketch it. Then what else? Let's see another question that you can do. Yeah. So genuinely, they don't really come a lot. They don't really come a lot. So I'm trying to see if I can get another. So far, it's only one person I've seen. On sketching that. Maybe I'm moving too fast. So there's paper one. Yeah, paper one, only one sketch question over there. Let's see paper two. Paper two. This is not asking me to sketch. This is also not asking me to sketch. Oh, there's a sketch question. Yeah, so there's an exponential sketch. We're told to sketch f of x. So this one, quickly, we know that the asymptote is at 1. And the y-intercept is going to be at 4. And there's a positive graph. So positive graph is going to look like this. So quickly, we sketch the curve. We get?
Yes, please.
Okay, so question number 7 also contains a sketch, but you can't sketch the inverse function unless maybe I teach you how to find the inverse, then you sketch that one. There is another way to do it by using the fact that they meet on the line y equal to x. It's something we've not done yet, so I don't want to really say much about it. I would confuse you the more. So when we do functions, we'll do functions next term. That will be the last topic we're going to do. We'll start with series, then we'll go to straight line graphs. Then we move on to circles, and we do functions to end it all. So next one is going to be quite stressful.
Sure.
Yeah, but you'll be fine. At least I'll finish up one full topic with you before you come to school. So yeah. Okay, take care of yourself, and we'll meet you.
Yeah,
You can use the textbook. You get more questions in the textbook than the past questions. Okay.
yes, sir. Thank you.
Yeah.
Bye bye.